Hi, Calculus. Today we are going to use our definition of continuity, and we are going to apply it to piecewise functions. If you remember, a piecewise function is a function that consists of two or more equations, each with their own domain, so a part of each equation. Each separate equation of the piecewise function is called a branch. All right? So let's go ahead and review, or learn how to put a piecewise function into your graphing calculator. So you're going to hit y equals, and right here it tells you in y1, right here, you put the first equation, then you need a division slash, and then the domain needs to be in parentheses. So it looks like this, right here. X plus 4, division, parentheses, x is less than or equal to 2, parentheses. To get to the inequality symbols right here, you just hit second math. That will give you the inequality symbols. All right, the second branch right here, negative x squared plus 8x minus 8. This has a different domain, but you want to break it into two parts. You want to break it into this part. I'm going to highlight it right here. Okay, so that means that 2 is less than x. And then we need the word and then we want to put the second part of the domain. I'm going to highlight the second part in blue right here. X is less than 5, and x is less than 5. And remember, we put that in parentheses. So that's written out for you right here. Right here, I mean. And it looks like what I have in y2. So here's our negative x squared plus 8x minus 8, division, parentheses, 2 is less than x, and x is less than 5, and your parentheses. And then finally our third branch right here, x is x plus 2, that's in y3. All right, when you graph it, it looks like the picture right here. All right, so we have this line, which is less than 2. We have this parabola, which is between 2 and 5, and we have this line here, which is greater than 5. So that is how you graph a piecewise function on your calculator. Okay, so now let's look at part B. We want the left limit. So what is our left function? Right here, x is less than or equal to 2. So less than 2 is to the left, so that's going to be our left function. So we want the limit as x approaches 2 from the left of that function, x plus 4. Now we have a limit problem, and we can do direct substitution. If I just plug in 2 plus 4, my left limit is 6. All right, now I want to find my right limit. What function is to the right of 2? Well, to the right of 2 would be right here. X is greater than 2. So that we're going to use as our right function. All right, when we're approaching 2. So I have the limit as x approaches 2 from the right, and I'm going to use that right function, the function that is to the right of 2, which is negative x squared plus 8x minus 8. Now I have a limit problem, and I can do direct substitution. So I have negative 2 squared plus 8 times 2 minus 8. Now, if you notice, up here in our equation, that negative is not inside of the parentheses. So the only thing I'm squaring is the 2. So that's tricky. That negative comes down. 2 squared is 4. 8 times 2 is 16, and then minus 8. Okay, so that's going to give me negative 4 plus 16 is 12. 12 minus 8, that gives me a 4. So my right limit is 4. All right, so as we move along, the left and the right limits are not equal. The left is 6 and the right is 4. So they are not equal. So therefore, the limit as x approaches plain old 2 does not exist, because the left limit 6 is not equal to the right. All right? So that's how we do that problem if we're approaching 2. Now, for the next part, is the function continuous at 2? Whenever you're asked if a function is continuous, you must use the definition, the 3-step definition. All right? So we know there's a y value at 2, but there is not a limit. The limit does not exist. So we would say no, and we would say step number 2 fails. The limit as x approaches 2 of our function does not exist. Okay, now we're going to do the same thing, but now we're going to use x is approaching 5. Now we have to figure out what our left and our right functions are. So right here, x is less than 5. That is going to be our left function for 5. And right here, x is greater than 5. Greater than 5 is to the right. So this is going to be my right function when we're approaching 5. Okay, so let's go to work. Let's do our left limit. The limit as x approaches 5 from the left, and we're going to use our left function, negative x squared plus 8x minus 8. And now we have a limit problem, so we can plug in. So negative 5 squared plus 8 times 5 minus 8. Remember, the negative is not in parentheses, so that comes down. 5 squared is 25. 8 plus 5 is plus 40 and minus 8. So negative 25 plus 40 minus 8 is giving me a limit of 7. So my left limit is 7. Now let's go over and do the right limit. So the limit as x approaches 5 from the right, we use our right function to the right of 5, which was x plus 2. Now we have a limit problem. Now we can do direct substitution. 5 plus 2 is equal to 7. My right limit is 7. So now in this case, the left and the right limits are equal. And it's a great date. So therefore, the limit as x approaches 5, plain old 5, is also equal to 7. Okay, finally, part E is the function continuous. Now remember, whenever you're asked if a function is continuous, you must use the definition. All right, so let's go to the first step. Step number 1. Is there a y value? Yes, f of 5 was equal to 7. So the y value exists. We are good. Step number 2. We know that the limit exists. The limit as x approaches 2 of our function was equal to 7. So the limit exists. We're good. And then finally, the third step, they are equal. F of 5 is equal to the limit as x approaches 5 of our function. So the y value is equal to the limit. Yes, that's our third step. So it is continuous. Now finally, of course, you want to check your work. So you always go back to the graph. All right? So here is 2, and here is 5. So let's check. Let's put in our imaginary lines. So at 2, just like we said, it's a bad date. The left is coming up here at 6. The right is coming in here at 4. So there is no limit, and our graph verifies that. All right, and then let's check. We also checked as x approaches 5. Hey, the left and rights are coming in at the same. So always go back to the picture of the graph and verify. Check your work. All right, finally, a couple things to clear up. To find and on your calculator, you hit second 0, and it will be in the catalog. All right, and finally, you can always hit y equals to find the y values in your piecewise function table. Okay, thanks calculus, that's page 1.